Good afternoon, everyone. Thank you for staying for the bitter end of the conference. I can see the numbers have dwindled, but I do appreciate you staying around to hear what I've got to say. We've heard a lot about AI in the last 2.5 days, and I want to spend 90% of what I'm going to say here talking about my perspective. I'm 42 Technology is a technology development consultancy, and that means I and my colleagues get very privileged insight into what happens in factories and so on across a very wide range of industries, not just printing. And it's curious to me that we get recurring themes coming up all the time. I probably get asked about AI every second meeting. Whether I've set up the meeting to talk about AI or not, the topic will come up. And a lot of the people that we speak to are manufacturers of complex products. And I would say that an ink is a complex product. I would say a printhead is a complex product. I would say a printer is a complex product. And for sure, from the point of view of the end users, the printers and converters who are using these printers, they definitely think these are complex products. So the themes I'm talking about here are highly relatable to what we see in our industry. I consider AI to be the cherry on top of the icing on top of the cake when it comes to using AI to control processes and to make sure that you're getting your manufacturing right. It can be amazing. It can do extraordinary things. But you do have to get the basics right. The whole concept of garbage in and garbage out is really, really true when it comes to using AI. And what's really curious is that if you do get the basics right, quite often you don't actually need to employ AI to get the results that you want. So what do we mean by the basics? There we go. It's been mentioned earlier today, but it's worth repeating and thinking about it. The basics of AI is data. You have got to train your AI on high-quality data, or you get nothing in return. And what do I mean by high-quality data? A lot of these will seem obvious, but I'll give a case study in a minute, and it's not obvious to everyone by any stretch of the imagination. The data has got to be digital. It's got to be in a searchable format, presumably some form of database. You've got to measure the right things. What do I mean by the right things? Well, do you have sensors with the right resolution, whether it's spatial or temporal? Does it have the right dynamic range? Are you recording the equipment that you're using? Are you recording the settings of that equipment that you've used? Are you recording the people who are using that equipment? And so on, and so on, and so on. These are all variables that go into manufacturing processes that can determine the outcome. And if you're not measuring it, there's a chance you're missing something. So I'm going to run through a quick case study. And by the way, although this case study is specific to one situation I found myself in recently, the themes here are very, very common. So I was invited into a factory of a manufacturer of a complex product. It turned out to be a safety-critical product. And it was core to about $500 million worth of business. So this is an important product. And however, the manufacturing process was such that the first pass yield was 60% only. Now, you could rework these things, and the end yield was 100%, but every time you had to rework something, that's just lost money. That's profit that you're pouring down the drain. And the question was, can AI help? Possibly. Show me your data. Yeah. A lot of the data to do with the manufacturing process was just written down on bits of paper by the technicians who were making the devices. If you were lucky, that bit of paper was then scanned in as a PDF and saved on a local hard drive. However, when the hard drive was full, they just started overwriting it. So it didn't take very long before they were losing data. Furthermore, they did not save the data relating to the devices that failed. Quite important stuff. And lastly, and almost as importantly, they didn't record what they did to the device in order to get it back working again. So that doesn't sound very good to me. If you want to train an AI on that data so you can start learning about where your process is going wrong and you can start deciding how to improve your process, you're stuffed. And sometimes the job of a consultant like myself is to tell the client perhaps what they don't want to hear. Respectfully, but nevertheless, if you want to train your AI, you need to spend an awful lot of time figuring out what data you're measuring and how you're recording it. So these guys actually employed 6 Sigma consultants one time to look at this, and they couldn't figure out how to make the devices better. So that immediately tells me you're not recording something very, very important. It would also seem that if you want to make progress in this, you're going to have to upgrade your IT infrastructure. And that's a big project in itself. This particular client couldn't go and store things in the cloud because it was so security critical that they didn't want to let the data off-site. So the key point here, though, is not necessarily the specifics of this very case study. This is normal. I can tell you stories in the last few months of 3 or 4 clients where the story was almost exactly the same. Some of them didn't even bother digitizing their handwritten notes. It'd be out in a warehouse somewhere. And the data they're measuring was really only to tell the end customer, this is what we think you've bought. And it was nothing to do with helping the manufacturing process people back in the factory how to make a better product. And ultimately, that's what the customer wants. So it's quite curious, and that's where, of course, 42T, we think we could step in, because being scientists and engineers, we'll step in and say, this is what you should be measuring, this is how you should be measuring it, here's a new bit of kit that we can design for you and install. But it really is quite interesting. But the good news is, with all these people, is you could say there is huge scope for improvement. So I like to think of AI as being right at the top of a staircase of processes that you can implement. And depending on the level and quality of data you've got, the further you can get up that staircase. But the data is critical. So you could hire a physicist like me, and we could write down some analytical equations, and we could probably fit that to a graph and extract some data. That's fine. You don't need a lot of data to do that, particularly if you think you've got a straight line. You only need 2 points, right? But if you go further and further, do you start employing spreadsheet modeling? Do you start employing multi-physics modeling? You need more and more high-quality data until right at the end, if you want to employ AI, you need stacks of it. Garbage in is garbage out. So the conclusion is, as far as I'm concerned, and bear in mind that if I'm seeing this in lots and lots of different industries, pretty much on a monthly basis, every time I go and meet someone new, it's likely that you or somebody like you recognizes yourself in here. AI really, really could be the analytics tool that you need. But in order to get AI to work, you have to do so much work gathering high-quality data, you might actually not need it if you start employing conventional tools. And that's quite exciting, because AI isn't perfect. AI will not tell you the insights it's got in order to reach the conclusions that it has. And speaking as someone who's quite fascinated by process engineering and process development, I'd quite like to know what's going on so I can really control what's happening. That you might get from analytical treatments, but AI won't tell it to you. Furthermore, machine learning type AI might be brilliant at controlling a machine, but it might be quite slow as well. If you can get to the point where AI is telling you which of your data sets are important. You can strip out all the rest in the final reckoning and just use simple process algorithms to control it. But you didn't need the AI to get there. And of course, it may be that for really complex solutions, AI is the only solution. So I'm just going to pause there for a second, because that was going to be my only talk, and I've rushed through it a little bit because I do want to say something else. I'm very, very happy to announce that 42T has recently signed a partnership with Fujitsu, who have been developing a huge bunch of AI algorithms. And I'm happy to announce that we, 42T, with this partnership, now get access to those on behalf of our clients, which is something that we're very excited about. You'll hear lots of people saying that they're working on this, but for people who need access to AI to develop new products, to develop new tools, this is something that we can now offer, and we're very, very excited about it. And if that wasn't enough, for one punchline, I've begged a little bit of leeway from the organizers, and I've got another punchline to come up with. This time last year, and a few months before that, regular visitors to FuturePrint will recognize that I was talking about RF drying. And then I went a bit quiet. Now, RF drying for me is the next technology that could be amazing for printing. We heard a bit about aqueous inks just a few minutes ago. There really is a huge movement to go to aqueous inks now. Now that we have industrial piezo-based inkjet print heads that are capable of printing water-based inks, everyone seems to be making a push to access the advantages of lower cost, safer, etc. inks. Big problem though, drying. Solvent-based inks, dead easy to dry. You barely look at them and they disappear. Aqueous inks, huge amounts of energy. If you go to the biggest corrugated printers out there, it's literally hundreds of kilowatts. Some of these places need a new substation built out the back to deal with it. So if you can come up with a method of drying that's significantly more energy efficient, that would be a big thing and really help kickstart the adoption of aqueous inks. And I've been talking about RF for a while because I think that could be exactly the technology that we want. But you can't buy one for the printing industry. It doesn't exist. So I'm happy to announce that over the past few weeks, myself and my colleagues thought, well, sod it, we'll do it ourselves. So here's a demonstrator of RF drying. I've just got some water in a syringe here, and this is an infrared camera to show you what's happening. The water is slowly heating up, everything's glowing nicely, and just to prove it really is RF, none of the rest of the system is heating up, it's just the syringe. And then as it starts to boil, the syringe pops out. Here's some water soaked on some paper. We're going to apply an RF field. And you will see, now this is sped up, I'm not going to try and claim this is real time, but as you can see, the water is rapidly drying. There is no hot air, there is no infrared, this is purely capacitive coupling from an RF electric field. And then my favorite one here is this. We've got a big pool of aqueous ink sitting on a thick bit of acrylic, and there it goes bubbling away. The whole video, you can see you start off with very non-viscous ink, and then as it heats up, it starts to boil. You can see it thickening and thickening, and then it starts to dry. So I've literally had people tell me that it won't work. I don't know why. I don't know which branch of physics they wanted to throw out, but here we go. It does work. And we are very excited to work with partners who would very much like to see a new drying technology out there to enable aqueous ink to get into the real market. And with 20 seconds left, my time is up. Thank you very much for your attention. I hope you enjoyed that.